Hello there, welcome to the problem session. Today we're going to talk about something that you probably already know, have some idea about it already. So how do we talk about image formation by reflection? In the last video we did image formation by reflection by using drawing arrays, and we use particularly convenient arrays to find the image. Here we're gonna not use that. We will simply use formula that you probably it's not that difficult to derive. We'll derive at the end, but just to tell you what the formula is, you probably know it by several ways to write it. 1 over p plus 1 over q equals 1 over f is one of them, and p is called object distance from vertex, and q is image distance from vertex, and f is focal point from vertex. So focal point, the way it's defined is of any lens or mirror is the same way. If this is the optical axis, and if you have a ray parallel to it, wherever it crosses say this is a mirror, say concave mirror, then this will be the focal point. That's the definition. Parallel will cross it. So if you have another ray that's parallel to the second one, this also cross the same point. If you have another one parallel to that, it also cross. So all parallel will cross. That will be our definition of what we mean by focal point. In the concave or convex mirror, it's a little bit different. So the mirror is like that. So just like here, if in this one, if your ray came from here, nothing will happen because this side is not reflecting. This is only this side is reflecting, and over here is only this side reflecting. So if a ray comes from this is nothing happens. Now, if the ray comes from this side and is parallel, it actually diverges. So it goes out like that. And so if you extend it, so then this is the focal point. So focal point is on the other side where the ray is. If I do another ray on the same side or this side, say another ray, it will actually bounce off in that direction. If I do another ray, it will bounce off in that direction. So this is the convex mirror, and this is concave mirror. Okay, so let me erase this. So we studied 3 cases before. This is concave mirror, and object is beyond focal point. Beyond focal point. And this is the case where concave mirror, object within a focal point. And this is any. So this focal is here. If you put an object here, nothing will happen. So you have to put object, you can put object anywhere. Okay? So that's the way to think about it. So coming back to this formula, you have all probably studied this. It says, okay, I have a P and a Q. Sometimes Q and F can be positive or negative. Another thing you may have studied is f is going to be either a plus or minus r over 2, and q can be positive or negative. And that's not very clear when I use this, right? So you tend to memorize the sign convention. But if you look at this, the way I'm going to write it, you really don't have to memorize the sign convention, because you just place along whichever direction object is, you just place the positive x-axis on that direction and write this guy as 1 over x coordinate of the object plus 1 over the x coordinate of the image equals 1 over the x coordinate of the focal point. So everything is here positive, so this is all positive. So here f is p is positive, object is positive, so this distance is the way I've defined here. This distance is the p, and this distance is f, and this distance is q. So instead of writing p, q, and f, I'm going to write this. So this is the x coordinate of O, which is greater than 0, x coordinate of f, which is greater than 0, and this is x coordinate of I greater than 0. So this is all 0 here in case, all positive in this case. Over here, if you look at, so in this case, all positive. In this case, you look at this, XO is positive, but XI is on the negative, so it's negative, and XF is positive. So this is the sign convention. So when you find something like this, you know you are on the other side. The image is on the other side. Over here, XO is positive. This is the XO. I'm on the positive x-axis on the other side, on that side. But the F here is, this is XF. XF is negative. X6 is negative. And XI, which is this XI, XI is the coordinate of this x coordinate of the image is going to be negative. So for this case. So this is sign convention. It's very easy to remember if you use x's and if you draw coordinate like that. Same thing for magnification. You may have studied magnification, which is usually written m equals to minus q over p. And q can be sometimes positive, sometimes negative, right? But if you write this as minus xi over xo, it makes everything obviously becomes correct, okay? So if here it's inverted, so m should become negative, and because both this is positive, then becomes m is negative. So in this case, m is less than 0. In this case, if you look at this and this together becomes positive, so m becomes positive in this case, and in this case also m becomes positive. All right, so these are some of the things you may have learned, and maybe a new notation where to use it. So a couple of things we want to make sure you know, that you don't remember which has f positive, which has f negative, right? So here is already this is negative, so this is f is negative here, and f is positive here, f is positive here, and just from this using the x coordinate. So magnification should be, if I have the size of this, so this will be y of p, y of object, y of image. So this ratio, this should be equal to minus x of image over x of object. So if this is positive, you can see that the of point Q, yi is going to be negative. So here, so in case 1, case 2, case 3, in case 1, y is positive, yo is negative. That means m is negative. And completely xi is positive, xo is positive. That also makes m negative. And the other cases work out similarly. Okay, so we want to kind of do at least one derivation of where this formula and this formula comes from. So usually we want to just remember f is r over 2, and this plus or minus comes from xf. Okay, all right, let's prove that f has to be r over 2. Okay, so let's look at this case, and see other cases will work out very similarly, so I'm not going to work out. So this is the mirror reflection side, this side is reflecting. So here's a P, this is object, and when ray is coming parallel to the optical axis, this is optical axis, that thing. So when it hits the mirror, it's going to reflect and go through the focal point, because this is concave mirror, right? So because this is a circle, this is spherical, and I have a cross section, so this is a circular, so this big circle. So in here, normal will be coming from this the point that connects from the center is where normal, right? So angle of incidence equals to angle of reflection. So these two angles are same. You can see right away this entire angle is 2 theta, and so this angle will be 2 theta. This angle will be theta. Now I'll show you that this formula actually requires a approximation. So if I take a perpendicular to it here, I'm going to hit this axis at some v prime, and we're going to use what is called paraxial approximation, where v prime, that distance, there's going to be a little difference. It's going to be way less than all the other distances. It's going to be less than fv. It's going to be v prime, v will be less than cv. Now this is distance we are calling xf, and this is the distance we are calling x. This distance is the radius, right? Or this, just call it f if you like, because too much writing x and everywhere, right? So I'm just going to do f. Okay, so in here I have, let's call it point A. So we have triangles like A, B prime, C, and the B is right over there. B is just next to it, okay? And we have A, F, V prime, and the V is just next to there. This is 2 theta, and this is theta, and this is 2 theta. So you can see tangent theta equals to a v prime, this distance, over c v prime, and over here tangent to theta is a v v prime over f v prime. Now what this approximation means that these angles are all small, so this angle will be close to theta, and this angle will be close to 2 theta, and AV prime is the same on both of them, right? So if I just say this divided by that, then it's going to be 2 theta over theta, and I'm going to have AV prime over FV prime times CV prime over AV prime. So A prime cancels out, and this, because of this approximation, this is just this one is just R, and this is just F, and theta cancel out. So bring F on this side, 2 on the other side is R over 2. So that's how you know where the F is. Okay, let's derive the other formula. So I just redraw this ray diagram for this case. That's the only case we're going to do today. Okay, so this is the ray and this is the reflecting part. So one ray is parallel ray that goes to the F. Another ray is to at the vertex, and it kind of reflects off this way. So they meet at the image point of point P. And so we look at POV and QIV. So this 90 degrees. This angle is equal to that angle because of reflection. Okay, so they are similar triangles. So corresponding sides should be proportional. So OP over IQ. So this is the heights of these two, and I'm not using y coordinate here, just using a distances here. This is the distances. This is equal to this distance opposite of that to the opposite of that. So this is OV over IV. These are distances. So this distance we're calling everything is on the positive side here. So this distance we're just calling this is the P and this is the Q. Okay. So that's one relation we can get, and we can actually look at another pair of triangles, and those will be this triangle and this triangle with V prime. So we have a one triangle is V prime A I, so this is same as OP distance, and the other one is a triangle which looks like this, and this was F, this F, I and Q. This angle is equal to that angle, and this is 90 degrees. So these are similar triangles. So they are similar triangles. So AV prime, which is same as OP. So let's call AV prime this distance over FV prime, that distance, should equal to, in this one is corresponding side is IQ, IQ distance, and then IF distance. So this one AV prime is same as OP, and FV prime is same as. So now we have to make a distinction. F to V is, so we're going to make a FV prime is almost identical to FV. We're going to make this approximation that we're going to make the approximation of VV prime. This distance is much less than FV prime or FV. So that FV prime is FV. Now this distance equals, this can be same as F. So OP and F. So this is going to be FV prime. There's a distance. There's a problem here. So AV prime, FV prime. Oh, so I should write it like this. Bring this guy over here and this guy over there. So AV prime is OP. This guy is OP, and IQ is IQ distance, and this FV prime is FV, and this is IF. Now let's look at IF. IF is IV minus FV. So this thing becomes OP over IQ bar, and which is left side of that equation 1, and the right side is FV bar over I'm looking for IF, so I go all the way to IV and subtract FV from there. IV subtract FV from there. Okay, so I got this. This is equation number 2. If I so left side of this equal to left side of that, so right side of this equal to right side of that. So let's look at right side, what that is. This is F and this is Q minus F. So the right side equal to right side, and now we're gonna look at what this equation, equating this with that, gives me. Okay, so here to write this, so we can try to simplify this, cross multiply. So I've got a PQ minus PF equals to QF. Bring this on the other side. So QF plus PF equals PQ. And then I divide everything by P times Q times F, P times Q times F, P times Q times F. So this gives me 1 over P plus 1 over Q equals 1 over F. So in this situation, we get this, and all of them are positive. P is positive, Q is positive, and F is positive, all positive. Okay, so that's the way you get the derivation. It's very clean. And when you apply the same logic, same kind of approximation into this guy, you get a little different equation. Let me show you what you're going to get, and you should try to get that. Okay, do the same logic and work it out. So we got 1 over P plus 1 over Q equals 1 over F, P greater than 0, Q greater than 0, F greater than 0. Now when we do this and we use all of this positive number, like the distances, IV equals to Q, IF equals to F, and OV equals to P. So we use this again. Then what we get quite a strange looking formula. 1 P plus minus 1 over Q equals 1 over F. So here the equation is not the same as that, except that if I think a little bit, not the distance but where it is, then I can absorb this minus sign into the definition of this, that this will be a negative. So if I say 1 over P plus 1 over Q prime equals 1 over F, now this Q prime is less than 0. And then this is the image from the vertex. I can think of the formula in the same format, but the sign will come. Or if I were to just write down x0 polynomial x image equals to xf. And so using this coordinate x, I don't have to worry about remembering sign convention. Okay, so now when you do this one, what do you get? So in this case, interestingly, you're going to get 1 over P 1 minus Q minus 1 over F, where these are just all them positive, chosen positive, okay? So P is distance OV, and the Q is distance IV, and F is distance distance FV. So everything from the corresponding distance, and you can come out this, but if you just look at the x's, so this is going to be XO plus XI equals to 1 over XF. So we're looking at this where the positive and negatives are located. You can see that I could have said this guy positive, and then this will be positive. This will be negative, right? It's going to come out as a negative, and so you can plus here, and so this. So either you use all positive and then you end up with all these signs, or you introduce a common formula, okay, but you remember the sign conventions and don't try to overcorrect it, right? You don't like include the sign convention and also go out and do one more sign conversion. No, you either use so if you use this thing, this formula, then you have to remember which case you're in, so you can actually figure out what the signs are, right? So I like to actually I try to remember the picture we are in and the coordinates I'm using. So I like to remember in this fashion, but a lot of people just go with this and sign convention. Whichever way you want to work this case and this case out yourself to actually see these negative signs emerge. If you like this kind of expressions, please tell your friends and hit the like button or share. Check out this my website. There's much more detail. The derivation is done there, and there are many other problems. Next video onward, we're going to start doing problems. Okay, I'll do some problems using 2 meters and things like that. Okay, see you in the next video.